I titled this presentation Dr. Graphite, or How I Learned to Stop Worrying and Love the Dots. There's a lot of criticism of graphite being slow and clunky and its dot notation being terrible, but I've never really experienced that, and I'm kind of okay with it. As an unintended side effect of this talk, I was like, okay, let me rewatch Dr. Strangelove and see if I can incorporate more of the movie into the presentation. And I wasn't able to do too much of that, but Dr. Strangelove is a really awesome movie, and if you haven't seen it, or if you have seen it, rewatch it and think about it from the perspective of someone in an operations team or in a telemetry system. And then I'm a security person as well, so I was thinking about it from a security and exploit realm. So it's really, really cool. Here's a little bit about me. Right now, I'm a systems and security administrator at Craigslist. Basically what that means is I do everything, help out wherever. We have a small team. So I get my hands in a lot of different technologies, and I don't have a lot of time to follow up with scaling things or babysitting technologies because I have to do so much. Wanted to give a little background about myself, why I've come to love graphite before I start spewing about how great graphite is and how you can scale it. I've spent the last 20 years programming in Perl, and I still enjoy it. And there's a few things about Perl that I enjoy that I've just found lacking in other languages or have become roadblocks. So one of the rules of Perl is to make easy things easy and hard things possible. This is one of the reasons why Perl was so profound in the 90s. Anyone could pick it up and start writing code and be on the internet and do guest books and all kinds of stuff. It's a well thought out language, mimicking the sloppiness and unpredictability of natural languages. And that's something that turns a lot of people off, but that's also why Perl is I'm still writing Perl today. The Perl that I'm writing today is very different than the Perl that I wrote when I first started in the 90s writing Perl. But because it has its roots in natural languages, it has that sloppiness and unpredictability that allows me to write either beautiful or ugly code. Perl makes starting a project easy. The hardest part to any project is getting it started. And removing impediments to starting projects is really important because most projects are going to fail, and that's okay. But if it's hard to start a project and most projects fail, you're not going to be able to get much done. Second worst thing is trying to use something in a way that you feel like it should. You're writing some YAML or some JSON config for something, you're writing a Logstash config and you feel like it should work, but it doesn't work and you don't know why. And with Perl, hard things are possible, and these types of transforms just kind of flow naturally. And the Perl that you write may be imperfect, but it usually works. This allows you to kind of grow with your user, and the joy of being able to see people use your tool in ways you didn't expect is truly awesome. Fundamental concept of Perl is DWIM, do what I mean. So what this is basically make the common use small, concise, and natural. So common use of carbon is carbonated beverages, so there's a little LaCroix joke in there. And with Perl, sometimes you want to start from the end and work your way back. You want to be more concerned about how you're going to be using your program, how you're going to be using these configs, than necessarily how to implement them. So you can work backwards. One of the phrases we coined in the Perl community is there's more than one way to do it. This is just comes out of the Larry Wall's natural linguistics understanding. We all speak different languages, we have different experiences, different backgrounds. You don't have to look any further than English to see the variety of slang and dialects, even in the same country. I spent some time living in the Netherlands, which is a very small country, and they spoke Dutch. But people from the south of the Netherlands couldn't understand the people in the north of the Netherlands Dutch, so they would speak English to each other as a common language. So there's a lot of variety. There's a lot of ways to inflect in languages, and Perl makes that possible in programming. And you always want to be aware of the one true way, the one true language, the one true editor, the one true program, whatever it is, just everything in life, just be careful careful when anyone has it all figured out. Embrace ecosystems that welcome change, that welcome new ways of thinking, that welcome interoperability. And then I spent 3.5 years at Booking.com between 2012 and late 2015. I learned a lot there, but some things are very relevant to why I love Graphite. So I wanted to share that with you. First off, to say Booking was data-driven is an understatement. I've heard lots of companies talk about being data-driven, but nothing on our site went live without going through our A/B testing framework. Our A/B testing framework was doing multi-A/B testing before that was even a thing that people started referring to as multi-arm bandit testing. We had rich data, rich metadata, we had aggregations of the data, and we had a very well-understood, well-documented, tight-knit group of analytics folks that were able to work inside of their domain and then share that knowledge with other people. Graphite became a part of this while I was there. And one of the things that's in every training at Booking, from your onboarding training to every training that you go to throughout your career there, is the Pareto principle. And the Pareto principle is also known as the 80-20 rule, that 20% of the work will accomplish 80% of the goal. And that last 20% is going to be 80% of your time. So why is this important? Like I said earlier, most projects fail. How many projects fail? Almost 90% of the projects that we worked on failed at Booking. So we wanted to optimize our time for that 10% of successful experiments that actually worked. So it was important to ship the minimal viable product and get it out the door. We tested in prod. In order to test in prod, you have to have rich telemetry and monitoring so that you can roll back very quickly. And then I was at Monotrauma in 2016, and Nicole Forsgren gave a talk entitled How Metrics Shape Your Culture. I think of it as a pre-flight video to anyone in the monitoring, telemetry, observability space these days. And if you haven't seen this talk, I really think that you should. Even if you feel like you understand metrics, monitoring, and observability, the talk is phenomenal and lays out some of the ethical underpinnings and the motivation of why you're doing what you're doing and what the impact of your monitoring of metrics could be on your company. I won't steal her thunder. It is an amazing talk. Please watch it. So that's a little recap of my journey that brought me here today. So now let's talk about my BFF, Graphite. When I talk about Graphite, I'm not just talking about the Python reference implementation of Graphite, I'm talking about the ecosystem that it created. And that's kind of important because there is such a rich ecosystem. There's so many things in this space. You can see how dominant it was just based on the number of other products that facilitate input and output via the Graphite metric stream. So why would I use Graphite instead of other things? So this is the important thing to hear is I have experience working with these systems. This was the right choice for me. This was the right choice for Booking. My experience introducing it at Craigslist has also been very positive, and I feel like it's a good choice for Craigslist as well. However, it's not a one-size-all-fits-all solution. You might be better served with something like InfluxDB or Prometheus. It might just make your life easier. Do what makes your life easier, but as you're doing it, think about some of the things I'm talking about tonight and make sure that you're able to grow with your business. So the primary reason that I'm talking about Graphite is because I know that it scales. Booking.com's Graphite infrastructure went from 50,000 metrics when I first introduced it to over 50 million metrics probably within a few months, and it's currently sitting at around 200 million metrics per minute that they're using. Now, Booking had another interesting use case for metrics that you don't see in a lot of other products, which is we were read heavy. We had 5 times the write load in reads because every metric that went into the system was monitored, whether it was by an automatic process or a series of other processes. There was lots of aggregations being computed, and metrics were being fed back into the system from those aggregations. So we were able to scale up things like Influx to handle our write load, but the second we would even move like a percentage of our read traffic to them, they would fall over on their face because they weren't designed to be constantly under that high read stress that may have changed. So this was probably 2014 when we evaluated that and made the decision to double down on Graphite. Graphite makes easy things easy. This is my Perl self coming out right here. So how do you get data into the system? Well, you don't need to pre-declare it. You just, if you're on a Linux system, you can echo your metric, your value, and your timestamp out to your local Graphite aggregate relay, and boom, you're good to go. You don't need to do anything. It's already there. I may get some, if you guys have used the Graphite Explorer, you may think that I'm being crazy when I say that this makes easy things easy, but this is a powerful data exploration tool. It's not a dashboarding tool. It's not trying to be. People who tried to use the Graphite Explorer as a dashboard don't like it, and I agree with them. It doesn't work very well. But for data exploration, it is amazing. Grafana has got a lot better. It's almost to the point where I don't need the Graphite Explorer to be able to do the same type of data exploration tasks, but to this day, like today, I had one tab open with the Graphite Explorer and one tab open in Grafana, so I can mock up what I want to do in Graphite and then move that concept into Grafana to make it more rich. And hard things are possible. Like, one of the things that struck me coming from the RRD days was you had to pre-declare your metrics, you had to pre-declare whether they were counters or gauges, and then in order to do any type of transformations, you needed to do reverse Polish notation to be able to do your computation. And while that's awesome and makes, I still know reverse Polish notation because I work so much with RRD tool, that's not a very accessible thing, and it's very difficult for new users to pick up. Here, I'm mocking up, let's say we have a read-through cache. This would give me the cache percentage. Even though I may not store the cache percentage, if I have the hits on the origin servers and the hits on the cache servers, I can mock up and then spit out a percentage of cache reads. It's not pretty, but it's possible. And then again, I came from the Perl community, so there's more than one way to do it is essential for me. And if you don't like a component in Graphite, you feel like it's not scaling, it's not meeting your needs, because the protocols and the APIs are so simple and well understood and well documented, it's possible to move those components out and replace them with things that may be better for your infrastructure. Just in Graphite itself, you can change between the Whisper file backend and the series file backend. And I've never used series, I've never needed to. Booking was doing all of their load on the Whisper backend. There's another tool called Carbon C Relay that was developed by Booking.com as a way to route metrics around the data center so that we could do maintenance, bring hosts down, lose hosts, and not lose any data. And then, of course, there's Grafana, and Grafana is its own rich ecosystem, not limited just to Graphite, but there's a ton of other dashboarding tools in the Graphite space. And there's libraries, right, for doing stuff programmatically. So here's one of my favorites, which is Rickshaw from Shutterstock. And if you just go into the Graphite documentation, you'll see over here, this is a screenshot of the list of integrations that are available and documented in Graphite, and this list isn't exhaustive. So this is just a snapshot, probably a percentage of what's available that works with Graphite right out of the box. If you wanted to use Graphite, you'd run into some performance issues. So what types of things do we need to think about when we're actually scaling out Graphite, the back-end system? So fair warning, when Mike originally invited me to do this talk, he wanted me to talk specifically about the Python implementation of Graphite. However, refactoring of the file writing, clustering, and Carbon link code was performed between 0915 and the 1.0 series. And like all refactoring, the intentions were good, and the team is awesome, but they introduced some sort of performance regression. It's a major performance regression, and I cannot recommend using the Graphite Python libraries at this point at any scale. You can easily do 1 million metrics per minute with the Python libraries, but if you're going above that, it's not gonna work. To give you an example of what type of performance degradation I'm talking about, I had a query that was doing 1,000 metrics, selecting 1,000 metrics using wildcards, and then performing an aggregation on it, it would take up to 60 seconds to perform that query because it was an intense aggregation on 0915. When I moved over to 1.0, I've never gotten that query to work. It times out even at 900 seconds. So there's something dramatically that's gone wrong. So I'm going to talk a little bit about how to work around that. And this isn't to discourage you from using the Python stuff. It might be easier for you to deploy the Python code than it is to deploy the stuff that I'm talking about here. But once you get to a certain level, you're going to have to start making compromises. I'm still running 1.1, the Python code, and we're doing 1.8 million metrics per minute, but it's definitely at its limit. So one of the first things that you might consider is replacing the backend that's performing the writing. The asynchronous file rewrite was one of the roots of this performance problem. And so there's a project called GoCarbon that replaces the entire carbon cache.py, which is the one that performs listening for the metrics on the network socket, having an in-memory cache of metrics, and then batch writing those off to disk. And GoCarbon will do that all for you, and it's completely compatible with the existing Graphite ecosystem. So you can just replace that daemon with this daemon, and you're off to the races. You don't need to change anything else in the infrastructure. The only thing to note is, like, if you do move away from the reference implementation, like when 1.1 dropped, it dropped with tag support, and tags took a little bit longer to come through to some of these systems, but it is present now in GoCarbon. Then there's GoGraphite. This is the code that Booking.com's business is pretty much based off of at this point for time series evaluation. So they have a lot of money riding on this code, and I trust it very much. And I know it's going to be well taken care of. There's three main components: Carbon Server, which serves as the in-memory cache and read-through cache for as a replacement for Carbon Cache. It runs parallel to GoCarbon, so GoCarbon will actually populate that and allow that to work, so you can run GoCarbon with a Carbon Server spin-off as part of the configuration. Carbon Zipper will sit in front of that, and what Carbon Zipper will allow you to do is perform, you can recombine metrics. So if you have a server that goes offline for a long period of time and you end up with a gap in the metric stream, and then another server goes offline and you end up with a gap in the metric stream, when you query both of those servers, that data will be combined together to form the most complete picture that it can before it's sent back to the user. So you can shard out your data, and you can lose data on an individual server without losing data at a higher level. Your queries will still complete. You want to backfill that data just to be safe, but in the meantime, while you're filling it in, you don't have to worry about it. It's also much more intelligent about returning. So one of the problems with the Carbon link protocol is if one server is down, the entire query fails, whereas Carbon Zipper will respond and say, okay, this is incomplete, but I'm going to give you back incomplete data because it's the best I can do right now. So be aware there are some trade-offs that are made, but those are made for performance and completeness of data. And then Carbon API implements the render and metrics find API in Graphite. It's completely compatible. Well, it's not completely compatible with the Graphite Web implementation. There are some functions in Carbon API that don't exist in Graphite Web, and there's some functions in Graphite Web that don't exist yet in Carbon API. The developers are very friendly, though. I've asked them to close the gap on that a few times, and they commit that stuff because I'm not a Go programmer, and they get it working really quickly. If you're going to be storing metrics at scale, you're going to need to use SSDs or NVMe storage. You're going to need solid-state storage, otherwise you're ice skating uphill. Don't shoot yourself in the foot like that. There's some things to be aware of. So this is actually from the implementation that we have at Craigslist, and this is monitoring SSD wear levels. And on the left side, you'll see I was like, oh, I'm super cool. I'm going to tweak some settings, and I tweaked a whole bunch of settings. And I changed updates per second to 3,000. And then I just went about my business. This is a year worth of data. So we have alerting anytime a disk goes above, 80%, 90% in wear level. But I had no idea that this was actually happening. I didn't actually look at this particular statistic. I didn't know that it existed at the time. And it was chewing through my disk. It was destroying the underlying storage because these files are being read and then rewritten to the storage so frequently with updates at 3,000 per second per instance, and I have 8 instances, so it's 24,000 updates, files written, read and read, all the way from the beginning to end per second. It's a lot of stuff. So then I made a change, and the change I made was I dropped the max updates per second to 200. And what that does is it puts pressure on the in-cache memory to actually expand itself. So in the first instance, I was storing about 1 to 2 minutes of data in the in-memory cache of the carbon daemons. And then after a minute or two, it was being written down to disk. With max updates at 200, I can't do that anymore. So I have about 22 minutes of data in the in-memory cache of the carbon instance. So what does this mean? Well, if I yank the cord out of the back of the server, I'm going to lose 20 minutes of data on any one instance. So I need to have replication in place to be able to ensure that I'm not going to lose data if things go away. Be aware there is a cost to some of this stuff. The other thing we want to do is we want to make this ecosystem fault tolerant, because there's nothing worse than using this new monitoring system and having a really positive experience only for it to go offline and not be accessible. You're going to be upset, you're going to be frustrated, and it's going to be even worse if you've managed to sell it to the CEO of the company and then it doesn't work. So what we do is we run local relays on all of our servers. They're Carbon C relays, and those are set to send to one of our relay servers in each data center. We have 2 right now in each data center. And what that means is any one relay can go down and the metrics flow back and forth with no issues. If we lose 2 relays, which actually I've wanted to do several times, I've shut down 2 relays because I knew my storage was going to be unavailable. The Carbon C relay daemon allows me to cache those metrics at the endpoints. So I don't have to use a ton of memory. Each machine can be responsible for its own in-memory queue. So that gives me the ability to have longer downtimes and not have as big an impact on any one machine in the infrastructure. And then when I turn the other relays back on, those queues will flush and push that data all the way back. And since Graphite can be updated out of order, it doesn't matter that it's a few minutes late or an hour late, it'll still work itself out. You want to make sure that you're replicating properly. There's a few ways to do replication. You can either just do a mirrored replication setup where you just mirror everything from one server to another server. You can use consistent hashing to distribute your metrics evenly across a pool of servers. With Carbon C Relay, you can actually intercept parts of the metric path and write those to different clusters. So you don't have to write just everything to everything. You can say, this is the application metrics. These will go to the application metric cluster. So if something goes wrong in the application metrics, they start spraying a whole bunch of data, it's not impacting my systems cluster, which I'm using for alerting and monitoring. And that's possible with the metric routing in Carbon C Relay. And then the other thing that you'll want to consider is make the common cases self-heal. Like I mentioned, I want to be able to reboot a storage node. I want to be able to take relays offline. And I don't want to have to do any manual process after it comes back up. And Carbon C Relay gives me that ability to shut a machine down and build up an in-memory queue and bring it back up again. I've had to do a round of firmware updates. It takes about 45 minutes for one of these servers to perform a firmware update and OS upgrade, kernel, and reboot, post, all of that stuff. And I've never had to go back and refill metrics because my queues have never overflowed, and when the host comes back up again, everything is written out. This is the config file for Carbon C Relay. It's pretty simple. This is what's on the endpoints. The important thing is, we have an any of declaration which just says send it to whichever one of these guys is up in response. And then we can perform aggregations, and the closer to the edge you perform the aggregations, the more aggregations you can do. So I use Diamond to collect metrics from my servers, and here I'm matching the Diamond CPU metric and forming aggregate metrics every 60 seconds, giving them at least 15 seconds to catch up, timestamping at the beginning of the bucket, and computing the average, min, max, median, 75th percentile, 95th percentile, and standard deviation to these metrics here. And you see we used a grouping capture on the regular expression here, and this is the first set. So \1 references whatever this regular expression matched. So we can use regular expressions, we can use grouping operators, and then we can rewrite those metrics however we'd like. From the servers where that is running, we end up with this pass off to a relay node. And the relay node is one or many nodes. In our case, it's two right now. And then that relay node is able to pass metrics directly to the storage backends, which then perform the write-downs using GoCarbon or carboncache.py. And then they can also send that data along to aggregator instances based on consistent hashing algorithms. So I'm looking at around 3 aggregators using consistent hash to push down, and then those aggregators will write directly back to the storage nodes as well. And what that gives me is the ability to take any one of these components offline and not lose any metrics. And actually, several of these components can be offline at any given point in time because Carbon C Relay will maintain an in-memory queue of data that's was a first in, first out implementation. So old data will expire and get pushed off the edge when you overflow whatever buffer it is you have set. Before I start talking a little bit about how I use the data at scale, I wanted to give you an overview of mistakes that I've seen people make and get really excited about, and then be disappointed when they find out that they're making some mistakes. So a wild graph appears, and I ask this, is this useful? And I don't think it is. I don't know what's going on here, and it even makes it more prevalent for you guys because it's very difficult to read these legends here. So what is this metric doing? What is the distance that this particular metric is doing? I don't understand that. My eyes don't make any sense. So what I recommend is when you're working with metrics that have a minimum of 0, that you set the y minimum equal to 0, because Graphite and other graphing tools are optimizing for the viewport. They're optimizing that series for that viewport of data. And if you want to see jaggedy lines, you can see jaggedy lines, and that's making the most out of this viewport, obviously. But this is actually a little less concerning for me because now I know what my scale is and I can actually see the jitter that's coming into this particular metric, and I know what it is at a glance. I actually used to have a chat bot when I worked at Booking because we'd be in the middle of an incident and people would be pasting Graphite graphs, and a lot of people would post like, oh, look at the way that this graph looks. This is the page view graphs for this particular demographic, right? They'd look at this, and then someone else would start clicking around in the metric explorer and they'd find a graph that looked very similar. And they're like, well, look at this. The page cache for this server is following the same pattern. And then you slap a 0 on it, and then it looks like a straight line. So you have to be aware of what your tools are actually attempting to do. So this is the 95th percentile of an arbitrary timer in my existing infrastructure. I'm going to change something about the data. And the use case that I want you to think about is dashboards in your office that are rolling through on monitors. So if you have a dashboard, it's rolling through on a monitor, you may see this graph, and then you may not see this graph again for 15 minutes. And it's on a completely different scale. It's moved along. We're going to do this in a few seconds. So you're kind of cheating, but I want you to tell me what's happening here. So I'm going to advance to the next slide, wait a second, then we'll advance to the slide after that, wait a few seconds, then we're going to talk about what happened. So you look off and you start writing code, and then this rotates back in, you see it out of the corner of your eye, and then it's gone. What changed? Did anything happen? Do we have an event? Do we need to start ringing the bells? Does anyone want to venture a guess? I know it is very difficult to read the axes there, but if you look at those two graphs together, the top graph is the first one we saw, and the bottom graph is the last one that we saw. All I did was apply a scale 3 to that series, which multiplied all the values by 3. Now, if you look at that, you can just visually see that the bottom graph looks actually lower than the top graph if you're not looking at the legend. And that's because the 5 in the top of that one graph got moved 1 character space over because now the top number is a 20. So our canvas shrunk, which means that the graph shrunk along with it. So how can we prevent these things? So here's a better example. This is the same graph. And let's say I know that this particular metric it starts getting weird when we get around 6 seconds, because this has to do with mail delivery, and it can take a while, so we don't care. But after 6 seconds, things start to get a little bit weird. So I can set also a Y maximum to 6, or in this case, because it's measured in milliseconds, to 6,000. So now let's do this. So we go back to coding. We had just seen that graph for coding. About 15 minutes later, this pops up. Now it's clear what's happening with the data underneath. So it's important to think about how your data is being used. If you're putting a dashboard up on a screen, or you're running a second monitor of dashboards, you want to be able to see, for me, with my bad left eye that can barely see, that something is going wrong on the other screen. And a sidebar about anomaly detection. Anomalies don't equal alerts. If you have 1 million metrics per minute, which is very low, and you look at 3 sigma, which most people do, that's 0.3%, and you measure these things per minute, you're going to have 4.3 million anomalies per day. And if you're on call, that's not a good day. So be careful, understand. If you want to do anomaly detection, I encourage you to, but understand the statistics behind it, the models, the parameters to the models mean something. Understanding your distributions are very important. Are you dealing with a normal distribution? Probably not. So if you understand that you're dealing with the long tail skewed distribution, then you can use models to detect anomalies in those, and you'll have a much better time. So these are some of the things that I use in Graphite that are my 80% workload. I use these in the Graph Explorer, I use them in Grafana, and I also use them for when I write code to monitor stuff with the JSON API, because I can get JSON data out of this and run it through analysis as well. And like I said, you're going to get a lot of use out of a small subset. So here's a graph. It just happens to be, these are the number of things that are getting indexed into an Elasticsearch cluster. And there's a bug in the appliance that we're helping sort out with the vendor that's causing this weird behavior. So we've been spending a lot of time looking at, like, what does the back pressure look like and what's actually happening. So we look at this a lot. But this is a 6-hour window of this data. And sometimes I just want to know, okay, how much data has gone in that 6 hours? And we can estimate that by looking about where we think the line of best fit is and multiplying it by per minute per hour. Or, because this is Graphite, all we have to do is call the integral function. And now I know exactly where I end up with. So we've moved our analysis of the data from the speed that the data is moving at to the distance the data has traveled using the integral function. If we need to go the other way, we have derivative to move the other way. In that case, we could move it to acceleration, because we were at velocity by showing how many documents are indexed, and then one step below that would be acceleration. That's cool. What if we want to know, what does that look like per hour? Well, we can do that transform very easily, and we can see where our peaks and valleys are per hour as we're going through and debugging this, because the vendor's logs are hour-based. So he wants to know, like, when did we see the least amount of logs written? And we can give that answer very quickly. So let's go back. We have this graph, simple graph. One of the questions that we often ask ourselves is, well, are we doing more or less than the last week? Because that will show us growth. We can easily add that in by using time shift. So we can time shift our series 7 days, and we get that green line appearing. And so again, we have speed. And so it's very difficult from this graph to tell whether we're doing more or less than we were the same time last week. So, it's Graphite. We just apply an integral to that series, and now we have the blue line here is this week's usage, and the green line is last week's usage. So you can see we were actually doing more last week. Why is that important? Because our traffic patterns are similar, so this appliance is going to generate a similar load, and we applied a patch that the vendor wanted in the time in between. So we expect the same amount of data because our traffic was about the same. We did not expect this gap. So simple graph, right? We like this. I like this graph. Is it misbehaving? Well, we get Holt Winters for free. There's a function called Holt Winters confidence bands. And you can see the green and blue dotted lines, the green being the upper, the blue being the lower bound. And we can see this red line is our actual data series, and wherever it crosses these lines is, that's where we're outside of what we expect. There's some sort of aberrant behavior occurring here. So what if we want to know how far out of normal this is? Like how far above the normal expected values are we in this period? We don't really know that. It's very difficult to tell. So we can use another function called the aberration to find how the distance from the expected values each of these particular points is at any given point in time. And if you're scared of negative numbers like managers, you can apply absolute to that, and now you have just absolute distance from the normal expected behavior. A few cool tricks that I learned. Alias by node is a function which allows you to select arbitrary points in the metric stream in the dotted notation to extract out and display as the label. It can take an index or an array, so you can specify multiple ones. Usually that would mean it would be alias by nodes, but the functionality got backported in. If you need to do evaluation of we want to divide this metric like free disk space by use disk space of one thing, and you want to do that across a number of servers, you can use map and reduce. They're kind of complicated. I don't really have a use case for them because most of the time we have those rollups, or we're looking at the system from a build perspective, so we're looking at the mins or the max or the averages or medians in those cases, and it's not as relevant. But if we wanted to monitor a host level, we might need to use map series and reduce series to be able to take we could do a glob and compare the top percentage used of memory using free mem versus total mem. And then group by nodes, which is pretty much my life. I use this function more than anything else in Graphite, and this is a metric string, a selector that says give me everything in the diamond namespace for host 1 CPU, every CPU metric, every CPU, so I've got 24, 48, 128 CPUs, and then also I'm concerned with the user and the system time. So then I apply group by nodes to that and select the maximum for that series at the first position and at the fifth position. And then what I get returned is host.user, host1.user, host1.system, so that I get the maximum CPU usage. So that you can also use any other aggregation function here, division, sum, median, percentiles. So there have been some really cool new features in the reference implementation, in the Python reference implementation, so I wanted to talk about them. I mentioned the first one already. It's metric tags. So here we have a series name, my.series, and we have a key and a value pair. They're separated by semicolons, and the key values are separated by equal signs. So you finally get tags in Graphite. It's native. It's all the way down, so it's all the way to the carbon link layer. So all of the tools that used to work for routing metrics around in Graphite also support tagging now. The support was added to Carbon C Relay and Go Carbon. The Go Graphite stack, specifically Carbon API, does not yet support tags because they have a separate implementation of tags called Carbon Search that but it is forthcoming, so that'll be there soon. And Grafana added support for tags in version 5. Also, some cool features, the pipe syntax. You saw a lot of those brackets opening and lots of functions. So now the pipe syntax allows me to more naturally compose complex queries by taking the result of this and passing it into this, and then passing it into this. So you can build these more complicated queries and make them a little bit more readable. If you're familiar with Grafana, this looks very similar to what Grafana does in their composer. You can create new custom functions if you need that functionality. Graphite Web works really well with the Go Graphite stack. So if you have a function that's not implemented in one of the Go implementations, you can use Graphite Web alongside of it, create your own custom function, and then use that server to query and get data out of it there. Xfiles factor has been added for runtime aggregations. So Xfiles factor is the percentage of the buckets that are being aggregated that need to contain data before the aggregation will yield a result. So if you have an Xfiles factor of 1/2 and you have 5 data points, you need at least 3 data points in that bucket in order to aggregate to a non-null value. That's something that's been present in the aggregation backend for a very long time, but for aggregation functions themselves, it's never been present. It's just been silently ignored. So now you have control over that, and you can say, I need at least half the data in this bucket before I aggregate. Supports Python 3, and 1.13 was just released today. I didn't see anything in the release notes specifically about the performance degradation, but I haven't had a chance to test because I just found it out as I was finishing this slide about 3 hours ago. So I'm going to test that out alongside of the Go Carbon stack this week. So that's Graphite. That's why I love it. That's what it is. Here's how you can reach me. I'll throw these slides up on speaker deck after this talk. And if you want to be a part of a really small team working on really big projects, we're always hiring at Craigslist. If you know someone that's interested as well, feel free to shoot them my way. It's a really cool company to work for, and I appreciate them allowing me to come out here and talk to you guys. There's free t-shirts and stickers in the back if you want them, and if there's any questions. Well, so what I'm running all of my stack on Red Hat servers, and we are using Python 2.7 as our, I think we're on like 2.7.12 or something. We're like two releases behind because the guy who manages the Python stack is on vacation. He's going to upgrade it when he gets back. I'm not using any of the C Python stuff. I'm not a Python programmer, so I don't know too much about it. But I've been working very closely with the Graphite project team members. It's a really great team of people. They're super responsive, they're super helpful, they're doing really amazing work, and they've done a really great job of refactoring the code, so it's much more readable. I understand it. I can like say, hey, this line, I think something's going sideways here. But I don't know enough about the asynchronous and threading in Python, and I believe that's where the core of the performance issues are. So I don't know that moving to a C-based interpreter is going to be any better, because I think that there's something going wrong in the threading code for the Python backend. Now, before 1.0 came out, I was using 09.15, which was pretty fast. I would say with the 09.15 code, you can probably support around 4 million metrics per minute on a single node with 8 writers on 8 Carbon Cache instances. Most people will run 8 parallel Carbon Cache instances and just consistent hash to them in a relay in front of it. That's totally doable on 09.15, but when I upgraded to 1.1, that number dropped dramatically, and we added some new metrics last week, and my entire cluster just melted. And so I have to keep it at 1.8 for right now, because I can't go over that. If I do, the system dies. The way that the Carbon Cache daemon works is that as new metrics come in to the Carbon Cache daemon, they become available for querying. So there's a read-through cache. So if you ask a question that's not in the cache, it will go back to disk to pull that data, and then it will merge that data set into the memory and send it back to you. So data is available the second that it is sent to the underlying cache node. Now, right now I have like 3 layers of Carbon C relay, and Carbon C relay is batching at each layer, so it's building these big packets and then sending big packets, so it's trying to be as efficient as possible. So I end up with about maybe 1.5 minute delay on new metrics being created through the system. But for the rest of the stuff, it's usually very quick. Yeah, good, that's another good question. So there's a lot of vendors in the space that will sell you monitoring as a service, and like Datadog, SignalFX, I have nothing but mad respect for them. They do an excellent job. We have a hard requirement that none of our data leaves our data centers. We run, and this was the same at Booking. We're storing business data here. If Amazon had access to, or Google had access to our data at Booking or Craigslist, they're smart enough to do stuff with it, and while they say they're not going to do it, that potential is still there. And then we're also relying on someone else for one of the most critical parts of our business, and that was not acceptable. So we do everything in-house. We did that at Booking. We evaluated a few service providers, but they just couldn't offer us what we needed for the price, and they also that was us giving them the keys to the castle. So I understand, like, if you're in a startup or a smaller company and you don't want to invest all the time and energy in the engineering of this platform, that is a really attractive solution, and I would recommend that you evaluate that as part of your plan. But for us, we have very strict privacy regulations at Craigslist. So no user data, no aggregated user data goes outside of our data centers, and it's all very strictly regulated. So it needs to be in our control. Cool.
Well, thank you very much, Brad.
Thank you.